you 10 calculus problems from my final exam review sheet. We will start off with completing an integral by interpreting its area. And we have the problem, the square root of r squared minus x squared dx. Now, we know that x squared plus y squared equals a squared gives us a circle. So, if we look here, we know that the graph is going to look somewhat like this. And since it's from negative r to r, that gives us our range. And when we use this area, when calculating the area for a circle, we use pi r squared. And since we know this is half a circle, we can automatically know, we can complete this integral by guessing the area of simply half pi r squared. Simple. Okay, second problem, we will be dealing with u substitution. We have the problem, the integral of x e to the 2x squared dx. Now with u substitution, you want to take the innermost function and make that u. So u will equal 2x squared. And du will equal 4x dx. We will then take the integral of this and we know that you can pull out a constant. So we will end up with 1/4 e to the u, since the derivative of e to the u is e to the u. And we will then proceed to plug u back into the problem. So we will have e 2x squared. We're plugging that back in for what we have right here for u. And our answer is this, or you could write it as e to the 2x over 4. Okay? Okay, problem number 3. We will be doing integration by trig identity. Now, when we are integrating by trig identity, you're going to want to memorize a few identities. I will give you a few. You are going to want to know that sine squared x plus cosine squared x equals 1. You're going to want to know that sine squared x equals 1/2 minus 1/2 cosine 2x. And you're also going to want to know that cosine squared x equals 1/2 plus 1/2 cosine 2x. Okay, so we are given the problem, integral of sine cubed x dx. We would want to break this up into sine squared x, sine x dx. Now from there, we would want to, we just use u substitution, and we would like to put sub cosine or sub u in for cosine x. So we will get well, first we get 1 minus cosine squared x sine dx, and then we plug this u in. So we get the integral of 1 minus u squared negative du, which can then turn into u minus u cubed over 3, and you always add your constant. And we'll come back up here. So since we have u in right here, we are going to plug back our u. We're going to plug our u back in. We get cosine x minus cosine 3x over 3 plus c. Then as a result, we get cosine x plus cosine 3x over 3 plus c. Okay, moving on. Problem number 4 will deal with numerical integration. With numerical integration, we will be using something called Simpson's rule. Simpson's rule allows us to approximate the integral using quadratic polynomials. We are given the problem using numeric integration, use Simpson's rule with n equals 2 parabolic sectors to approximate the integral from 0 to 4e to the x squared dx. Now, Simpson's rule tells us that we must use h over 3 y sub 0 plus 4y sub 1 plus y sub 2. Now, when using this integral, we would like to sketch a graph that looks somewhere along the lines of this. And in order to do this, we would need all these points. So we have e here, we have e to the 4th, we have e to the 9th, and e to the 16th. Since our h, our height of the equation is 1, we have 1/3. Then we would have 1. Since e to the 0 is always 1, then we would add 4e right here, and then e to the 4th. We would add, since we still have 2 more of these, we would add e to the 4th. So we are taking those 2 chunks and adding them together. E to the 4th plus 4e to the 9th plus e to the 16th. Now, you could leave your answer like this, or you could rewrite it as 1/3 plus 4e to the 3rd plus 2e to the 4th over 3 plus 4e to the 9th over 3 plus e to the 16 over 3. Either one of these would be correct. Okay. Problem number 5. We are dealing with the DISC method.